Hello friends, in this video we are going to look at closures and lexical scope in JavaScript. We will also look at how inner functions work. Inner functions and closures. In JavaScript, you can place a function inside other function. So in Oops, you maybe heard about inner class, right? So the same way here, JavaScript supports inner function. That means a function that contains one more function definition inside it. So this creates the concept of inner function. That means placing a function inside some other function. Then the function which is inside is called the inner function. To learn inner functions, we need to know what is lexical scope and closures. In JavaScript, closure is a combination of functions and data variable in its outer scope. So it can be any function, a function or an inner function. So when it is a function, the data variable and other function in the outer scope is the global ones. So if it is a inner function, whatever is outside the inner function is called the outer scope. So these altogether forms the concept of closure and lexical scope. So some people call it as a lexical scope, and some people will call it as a lexical execution environment. When you create a function, a closure is created for us, as well as lexical scope also created. Lexical scope or lexical environment refers what a function can access outside its body. We know that when we declare a variable inside a function, these variables are scoped towards the end of the life of the function. But this lexical scope and lexical environment refers what a function can access outside its body. So to better understand the closure and lexical execution environment, we will start looking at the inner function first. Here, if you see in the script, we have a function called counter, and the counter declares a variable count. So this variable is scoped inside this function. So outside this function, we cannot get the count and increment it or read the value of count. Here we are having a function add1 that increments the count and returns the count. If you see here, the outer function is counter and inner function is add1. So the inner function can access its internal variables. Here there is no internal variable in the function add1. If you declare one, you can use that inner variable inside the add1. So it can access the inner variables as well as variables defined outside it. So here the variable count is defined outside of the add1. The count is scoped to count1. I mean, the count is scoped to the function counter, but it is also scoped to add1 also. But outside the counter, you cannot access the variable count. So let us say that before the end tag of script, if you access the counter count equal to count plus 1, then that is not possible. Why? Because the count is inside the counter, but count can be accessed by its inner function add 1. And one more strange thing what you are seeing here is we are returning the function body, the entire function content we are returning. So as already told, the scripting language, Java scripting language is typeless. So a function can return anything. So it can return a function also. So here we are returning the function add-on to its caller. So if somebody is calling the counter, there are two things that happens. So the counter initializes its internal member or the internal variable count. Then it returns a function definition for add-on to its caller. See here, if we make a call like this, where inc equal to counter, the right hand side of the equal to will get executed. That means we are making call to counter. The variable count is initialized to 0. Then it returns the content of add1 to its caller. So the where inc will now have the body of the function content add1. So we can experiment what is there inside the inc, because we are making call to counter. The counter is returning a function. So let us print what is there in the inc. Then we will proceed further. Now it's demo time. We will see what happens. Here if you see, the body is just simple. So before that, let me cut this so that you can see what is the HTML content. So the HTML content is just simple. There's a header tag, learn JavaScript. Then inside the body, we just kept some h1 tag. But we are making call to print in the onload of the body tag. That means whenever you open this JavaScript demo in browser, it will call the print method once. So during the load of the HTML document, that's the event here, right? Onload. So just like if you are a C# or VB programmer, you will have form load, right? Likewise here it is a document load. When document is loading, we are hooking that to the print function. Now this is the print function. This one we already explained in the slide. Now let us look at a print function. In print function, we are making call to counter and we are collecting that inside the inc. Then we are just printing the content of inc. Let us execute this and see what happens. Let me save it once. Okay, already saved. So the first document.writeLine, whatever we are writing is content of inc is. So that's what here printed, content of inc is. Since we have a break here, we come to next line. In the next line, we are printing the content of inc. So if you see the inc content is function add1. That's what here we are returning, right? You can see the same content is printed here. The only difference is there is no formatting here. You are seeing the entire function in single line. Function add1, open curly braces, count equal to count plus 1, then the return count. So the main function returns this sub function and the sub function is returning the count. But here we are making call to counter. the main function. So the return value, we collected it in inc and we printed that inc, and inc is printing the function content add one. Next we printed this line, right? Now let us go back to our slide. Just now you saw that inc is printed the function content of add one. Now let us continue with the closure demo. Let's understand how JavaScript closure and lexical scope works. So this function you already saw. So this one also we already saw. We are making call to counter. What happens here? It creates a lexical scope or the lexical execution environment. Even though the function is returned, here we are making call to counter, right? Once the counter returns, we will have a function body inside the variant. That means the variable inc. So even though the function returned, since the function body add one is referring the count member of the counter function, the count will not be removed from memory. So we will have count in a memory even after returning from that function. So normally in function, once you return from the function, the internal members are cleared, right? So here in JavaScript, since we are holding a reference through its internal function add one, and add one refers the outer scope count, even though the counter returns, the internal member count will not be cleared. So at this stage, we are having a lexical scope for this inc, and it has a member called count, and count is holding a value of 0. Why? Because after initializing count to 0, it returned the function add one. Now inc is the content of add one. Next, what we are doing, we are making call to counter again, and this time we store the return value inside a different variable inc2. So once again, this will make a call to counter and it initializes the count, but this time the count is different. So now you are seeing two lexical scope for one closure. The closure is for counter, but you see two lexical scope or the lexical execution environment. There are two execution environment. One execution environment is on count variable for inc and another one is for inc2. So they both have two different count internal members. Here in the document outline, if you see, we are making call to inc. So we know that inc is body of the function. The body of the function is add one. When we printed the inc content in the previous demo, you saw that it printed the content of add one. So that's nothing but a function, right? inc. So here we are making call to inc by placing the open and close parentheses. So first we are making call to inc. So you know what is the content of inc. So it's nothing but the add one function, and we know what add one will do. Add one is incrementing the member count. So the count, the maroon one you are seeing in the top, that will get incremented to 1. So that's the execution environment for inc, right? So the next, we are making call to inc2 3 times. So now in the second execution environment, the count will get incremented 3 times. So finally, we are making call to inc one more time. So this will increment the count, the maroon one once. So you see here, there are 2 execution environment, and before printing the line, or at that stage of printing the line or printing the last statement, the content of count is 3 and the content of inc2 count is 2. Sorry, I told it in reverse way, because inc2 we called 3 times. So the yellow count is 3 and the maroon count is 2. Once again, let me reiterate here. First, the counter is having an inner function, and this forms the lexical scope. We are making call to counter twice, so we have two execution environment. Even though the function counter returns, the returned value is a function, and that function refers the outer scope count. So even though the function counter returns, its internal member count is not cleared because of the referring function. Next, we incremented the counter by calling the inc and inc2. So there are two execution environment, so we get two increments. One is on the first count and the other one is on the second count. Alright, now it's a demo time. Now let us implement this and execute. So here is our print function, right? Now here if you see, we are not making call to the inc function like that. We are just printing the content previously. Now we will make a call to that function. See the difference here. We are printing the content of inc. Whatever is there in inc, we are printing it. So we already saw that it is actually a function, add one. So here now we are making call to that inc since we know it is a function. So in the slide we saw that there will be two execution environment. So the same stuff here we added it. Now we will execute and see how the counter increments for inc and inc2. So this one we already saw. If you see here inc, the counter is 1. For this time we are making call to inc2, so that counter also initialized, I mean the incremented. So that's the body content you are seeing here, right? First it add 1, but the execution environment for inc is different. So count was already initialized to 0, count equal to count plus 1, so this will give 1 and we are returning that count. So that's why you are seeing 1 here. Similarly for inc2, when you increment, you are not seeing 2, but you see 1 here. Why? Because there are two execution environment or two lexical scope. Next we are incrementing the counter, second counter we are incrementing, and you see the sequence here 1 2 3. Next we are going back to inc and we are incrementing it once. So it incremented from 1 to 2. So you see the two different counter variable right here, I mean the count variable. So this is what called, there is one closure but there are two execution environment. So this one is for the first execution and this one is the second execution environment. Alright, now let us go back to our slide. Alright, if you see here, the user, we can call the counter any number of times. So if we call it 4 or 5 times, we get different lexical execution environment and there will be different instance of the count member. So how do I create a global counter so that user cannot make a call to counter, but there should be a way to track a count with only one lexical execution environment. So this will make us to move to the next concept of self-calling function and closure. So the self-calling function, in the sense here, if you see, we are making call to counter. That's why we get two different execution environment. So instead, we should suppress calling the function, but we should at the same time use a global variable that contains the internal member function add1. So this makes the lexical environment created only once. Then user can make a further call to the add1, so that there will be only one count. If you see here, the same content we kept here, and before function global counter we opened a parenthesis, and that parenthesis ends at the last line. So what this tells us is we define the global counter function, and at the same time we are executing that function. So executing, in the sense, here we are making call to that function with two parentheses and a semicolon. So the function is defined here, it is called here itself. So since we placed a parenthesis before defining the body, so before the function keyword is there, right, function global counter, before that we placed a open parenthesis, and there is a matching closing parenthesis down. So that tells that the function cannot be called outside. Why? Because it is enclosed here. Then the next two parentheses, open and close parentheses, that tells that the function is called here itself. So the function is defined and at the same time it get called. So since it get called, it will return the function add1, and that is collected in global counter. That's all done here. So the global counter cannot be called afterwards. So this makes sure that the global counter is executed only once. Since it is executed only once, there is only one lexical scope here, and there is a count variable which is associated to that lexical scope. So here global counter contains a lexical scope, and it has a reference for a count variable. Now if you see here, we cannot call the function global counter. The only way to call add1 is through the variable global counter. So that's all here. So this way we can create a global counter. Here this code will print count 1, 2, 3. Now it's demo time. We will go and alright, now we will define the self-executing function. And if you see here, this is the function body. If we take out this, you can see it easily. So that's the function body, right? Function global counter. So what we are doing, we are enclosing this with a bracket stating that the scope is done here itself. So you cannot make a call to global counter outside. By placing a set of parentheses, what we are seeing, we are executing the function here itself. So when you execute the function here itself, it returns the inner function add1. So this add1, we are collecting it inside a variable where global counter. You see, so the syntax may be confusing, that's why I typed it here once again. So now you get idea of particularly this line. So it may be slightly confusing, right? Now we got the idea. So this is the function. This parenthesis, you can see the red highlighted one. This states that we are defining the scope here inside so that it cannot be accessed outside. Then this parenthesis is for executing this body here itself. So that's the way we call, right? So we are calling the function body is defined here and self-executing. So here we are executing the body immediately after defining it. It will return something. That return value is told here in the global counter. Alright, now here the global counter is ready. Now we will use it. If you see here making call to global counter. So there is no way to access this global counter function like we did previously for counter. Here we are calling counter 2 times, right? So this is not a self-executing function. So we created a 2 counter, inc1, inc2. Thereby we created a 2 lexical execution environment or 2 lexical scope. Here for global counter, since it's a self-executing function, the execution is done here itself. That means, so once the execution is done here itself, it initialized the count to 0, then it created a lexical environment with a variable count. And we have global counter. There is no way to call global counter here. We have a variable global underscore counter, and this one is content of function add1. So here we are making call to global underscore counter. That means we are making call to function add1, which increments its lexical environment variable count and increments that by 1 each time. So that's how here you will see 1, 2, 3. Now let us execute this. So here you are seeing 2 different counter, right? Here there is only 1 counter. You cannot create 1 more counter because of the self execution function. Alright, that's all in this video. Thank you for watching. Bye.